All right, let's take a look at concavity and rates of change for quadratic functions. So a quadratic function has a graph that is either entirely concave up or entirely concave down. Okay, so let's look at two word problems here. So high diver. A high diver jumps off of a 10-meter platform. For t in seconds after the diver leaves the platform until she hits the water, her height h in meters above the water is given by this formula here. So h is equal to f of t, which is negative 4.9 t squared plus 8t plus 10. Estimate the domain. So the domain is going to be the independent variable values. So it looks here like it's going to be between 0 and about 2.5. Okay, and then the range, that would be the dependent variable value. So it looks like our lowest is about 0. And our highest is maybe around 13. If we wanted to find these exactly, there is a formula for finding this guy here. It looks like that happens at 1, so we could try finding f of 1. For the domain, to find this number here, what we could do is take f of t and set it equal to 0 and solve. Okay, but since it said estimate, we're good with those. Next question is, what does the h-intercept represent? So here's the h-intercept. And this is the height of the platform before the diver takes off. Okay. So this is the height of the platform. And then the t-intercept, so here's our t-axis, and that makes this our t-intercept here. And this represents the height above the water. So when we get here, she is hitting the water because her height above the water is 0 now. So this is the time that the diver hits the water. And then if we look at the concavity here, this has that umbrella shape, so this will be concave down. And it's totally fine if you abbreviate concave as C down and C up. That's pretty common. You'll see that a lot. Anybody that goes on to calculus will see that as a pretty common abbreviation. And I'm totally fine if you want to do that, or CD or CU, that works also. Right, and then let's look at a parabola that opens up. So this is a book autograph signing reception. The equation below models the number of books, Y, sold in a bookstore X days after an award-winning author appeared at an autograph signing reception. So the first question is, how many books were sold on the day of the reception? So that would be day 0, because these are our days, and this is the number of books. So on day 0, that would be like plugging in x equals 0. So that means y is 0 squared minus 12 times 0 plus 38. So that leaves us with 38 books that were sold on that day. What is the smallest, the minimum number of books sold? And since this parabola opens up, we get a min here. So we can actually just read this right off the graph. So 2 books is the smallest number of books sold in a day. And then on what day after the autograph signing did that occur? So day 0 is when the autograph signing occurred. And this is at the 6th day. So 6 days after the autograph signing. All right, and then estimate the range. So the range is going to be that dependent variable, the number of books. And we already found out that the smallest number of books is 2. So we know that y has to be greater than or equal to 2. There's obviously some sort of upper bound on there in terms of there's not an infinite number of books, right? But this is acceptable to just identify that lower bound. And if you're not comfortable with that, feel free to make a note like max is number of books published, maybe. But I'm certainly fine if you just want to write y is greater than or equal to 2. And then identify the concavity. So this one here looks like a bowl. So we have concave up. All right, and what I'd like to do, we have a box down at the bottom. Let me zoom out here. So I want to see if we can actually figure out if there's a rhyme or reason to the concave up and concave down, and if we could just look at the equation and not even have to graph it in order to figure that out. So let's look at this a value here. So a is greater than 0 or a is less than 0. That's that number that's in front of the x squared. And remember that a cannot be equal to 0, otherwise we don't have a quadratic function. Okay, so a is either bigger than 0 or a is less than 0. So when a is bigger than 0, like here, so here our a is 1, our parabola opens up. And that's going to be true for all parabolas where that a is greater than 0. So it's going to open up, and that function will always be concave up. Now, if a is less than 0, like it is here, so here my a is negative 4.9. If that's the case, then my parabola is going to open down. So anytime that x squared has a negative number in front of it, your parabola opens down. And that means that your function is also going to be concave down. Okay? So you can tell that just by looking at that function. You don't need to graph it to figure out the concavity.